you do if I ask you to move mass?
Tie
Push
the
it.
rope and
All right, applied force, right? So you apply some force. Now I'm going to give you two graphs, right? The graph one is you're going to friction versus time. If I at 1 second, at the end of 1 second, if I applied 0.4 Newton, would the box be moving left?
No.
Okay, good. So what would be the maximum force of friction be possible? Okay.
1.
Okay, 1. 1 would be the maximum. So I'm going to draw a graph and you're going to tell me, Isaac, you're going to tell me what is the name of the red line in terms of notation.
Oh, static friction.
F.
static friction.
FFS. What is the name of right here?
Oh, FFS equals FA.
No,
No, FFS max.
FS max.
Oh.
What is the name of this one?
FFK.
That's true. FFK. Now come over here. So this
Okay,
graph and this graph are similar.
Yeah.
Agree?
Yeah.
Uh-huh.
Okay, here, let me see. If you apply at 10 seconds, if you apply 10 Newton, what would be the force of friction?
0.9.
0.9. Okay, so 0.9.
Oh, that's what it says on the graph.
Okay, good. Graph, if I apply, let's say at 20 seconds, if I apply, at 20 seconds, if I apply, I don't know, 30 Newton, what would be the force of friction?
0.9.
0.9. Okay, let's come back over here. If I apply 0 Newton, what would be the force of friction?
0.
0.
If I apply 0.5 Newton, what would be the force of friction?
0.5.
If I apply 0.9 Newton, what is the force of friction?
0.9.
0.9.
0.9. Would the box be moving?
No.
No.
Not yet. If I apply 1 Newton, what happened? Force of friction?
It
One.
suddenly moves.
It suddenly, okay, so it suddenly moves.
Mhm.
Isaac, it is right now?
Yeah.
Okay, good. So what is the answer to question number 1?
Based on the
we
graph,
will
find the force of kinetic 0.92.
0.9.
0.9. Okay, how do you find this question?
Well,
Answer.
the thing is, it gives you this graph,
Mhm.
and the block is started in motion when the applied force and the force of friction consequently is exactly 1 Newton, meaning the static force of friction max is 1 Newton, and then it immediately drops to 0.9 newtons, meaning that the constant kinetic friction is 0.9 newtons.
Okay, excellent. Okay, 50 kilogram object moving with 100 meter per second, right? All right. Okay, so what would be the momentum at the x direction?
Well, 0.
What would be the momentum initial at the y direction?
5,000.
5,000. 5,000 is wrong. 5,000?
Kilogram meter seconds.
That is correct. Now, what happened when you throw a granite? It hit the target, right?
Mhm.
And it broke into how many pieces?
Let's say 3.
2 pieces.
Oh.
2.
You need to learn how to read. Okay. 2 pieces. The first pieces moves to what direction?
North.
West.
North.
West.
Why don't you learn how to read? It literally says W, my God.
Okay.
You can't just.
All right. Good.
Idiot.
And what is the mass?
25.
Oh no.
So,
25. Okay. Good. 25. Then if this one is 25, this one must be 25. Conservation of mass. And what direction this guy is going?
It's unknown.
No. It tells us.
Northeast.
Northeast.
Upward.
Northeast.
Yeah, but you don't
Okay.
know the exact direction.
That's
Okay.
what you have to find.
That's
Yeah,
what you
I
have to
know.
do. Okay. Isaac.
No.
All right. Isaac, you do it. Come.
Is we want to add the total x momentum initial to be the same thing, the total x momentum after, and the same thing with the y momentum.
First do X here. You do X only.
So what?
He'll do Y.
Oh, dang it. Alright. Well, the thing about this is, so we have P initial is 0 because it's just one piece, and P final is plus M2 V2X because,
Yeah, sure.
you know. So let's see, we have 0 is equal to, and just to clear up any misconceptions, I'll write V1X2. So this one is 25, and it's going at a velocity of minus 10 in the x direction. Remember, this side is positive. And plus M2.
Initial momentum in the y direction is equal to final momentum in the y, right?
Yeah.
So initial momentum in the y is just this one. So mass.
No, we already find it. Just write 5,000. Come on.
Just 5,000. Okay. So this has no initial momentum in the y.
So
Only
you
this
write
one.
the equation like Isaac, M1 V1 Y.
Okay. M2 V2y. So this one is 0, right?
Mhm.
So this is 25 times 0. And this one is what we are trying to find.
Right.
This is also 25 V2y. So 5,000 is equal to, this is 0. So 25 V2y. So V2y is 5 over 25.
That's
Which
200.
is, let's see. So 200 meters per second.
Okay, so Isaac, you're gonna do vector addition now by head and tail.
We have this 200 meters per second in this direction. Then you have 10 meters per second in this direction. So you're going to want to bring this up so that the tail is at the head of this vector. So this is 10 meters per second. And then you can basically do the addition from there. Let me erase this a little bit. So then you just add these two by the Pythagorean theorem.
All right, 87 is very close to 84, so 84 is the answer.
Yeah, crappy estimation for the win.
Okay, now.
This slide.
Okay, so
Calculate the speed of Isaac at the instant he reaches the bottom.
okay,
of the
so
slide.
this is the competition between Isaac and Raf.
It's not
Okay,
an exact right angle.
All right, so no, it doesn't matter. Okay, look, conservation of energy work. It doesn't have to be right angle. PE top is equal to KE bottom.
Wow.
It doesn't have to be right. Is this right angle?
No.
Okay.
For him it is.
Okay.
No, I'm just saying that diagram is extremely misleading.
That's right. 1.5. Okay. 1.5 meter, right? 1.5 meter. Is that right? This is
4.2.
2 meter. And acceleration is 0.3
3
meter per second square. And mass is
40 kilogram.
kilogram. Now, both of you gonna do it. All I want you to find, the first I'm gonna give you the answer very quickly. What is the velocity initial?
0.
What is the velocity final? You're trying to find, right?
Yeah.
Okay, good. VF square is equal to VI square plus 2AD, right? So VF is equal to VI square plus 2AD. So VF is equal to 0 plus 2 times 0.3. D is how much? Guess. D is how much?
D is 4.2.
4.2. So B is 1.6. VF, right?
Yeah.
Now the challenge is you're not going to do it this way. You're going to do it conservation of energy. So my challenge is both of you. You're going to find what? The force of friction.
I'll just assume that it's 1.5 meters tall for now. So then we get that. So U equals what's it? mg. Oh, I can't even stand up straight. That sucks.
Can you, instead of EU, can you write PE? Because resonance physics use PE. Thank you.
Why does it give answers like that? Have you seen this before?
Yeah, but you have to write as a unit.
Do we use
You have
9.8
to.
or 10?
9.8.
Okay.
What happened?
He wrote potential energy top is equal to kinetic energy bottom.
I didn't even do anything.
That was the point. You didn't do anything, correct?
I'm going to hit you. Okay. I like how it cooled down so quickly. I know Repath is just salivating in the mouth. They're like juicy balls. Okay. So v squared 4.2. Oh, it's an inclined plane problem. I see, cheeky fellow. And what is that? Time. How am I blanking on this? This should be the easiest problem. Oh, right. So you have that.
Should I give you a hint?
No!
Okay.
Which is split up into that. And then that. Now this one is that. Which means the other one is that. And then the other one is that. Times the coefficient of. Oh, right. Okay, so minus that, and that is equal to MA.
No, don't say loud because you don't want to. You want to get it faster than.
It'll be fun. 12.
Oh, he said everything loud.
Oh, thank you.
I'm trying to help you out, you dolt. Because you know you're going to lose. You know very well. Opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. Okay.
Done.
Oh, damn it. Oh, it sucks.
Do we have to find final velocity?
Hold on 1 second. You're gonna have to find the final velocity. Yeah.
Okay.
And final velocity has to be same 1.6. Should I tell you to find the work done?
No, don't.
Work done by friction.
Oh my freaking heck. Oh, I know the work done by friction.
Do you?
Trust me, it's this. Wrong, right?
Work done by friction is F times D.
Yeah, so it's that.
Yeah, sure.
I'm gonna stumble and fall, which is honestly great. Personally, I've always wanted to stumble, fall, and oh shoot, that's not family friendly. Okay. Find the final velocity.
Me too.
No, you didn't.
I did.
You're still finding the kinetic energy. Okay. This is the answer, right?
Yeah, that's 1.6, I believe.
Yeah. Then I'm done.
Okay.
What, you thought I was going to throw something at you?
Okay.
Could you be right?
No. No, don't do that. I said I'm making it for my student.
Oh, okay.
Okay.
Okay, very nice. Okay, so Isaac secretly made a catapult to hit Albert.
Yes!
Okay.
You mean Rifaf, right?
Yeah. Okay. Okay. Here it looked like. And Raf is 2 meters away from. 2 meters away from where?
Catapult.
Catapult.
Then why can't I just run up and hit it myself?
And time is how long? How long does it take?
0.8 seconds.
0.8 sec. Okay. And height doesn't matter, right? Height doesn't matter.
Size
So
does not matter.
no, okay. In this case, what do you need to find? Velocity. Velocity has how many components? Two components. Whose component you want to
Getting the
find?
height, actually.
Vx. Yeah, but you don't need it. So d is equal to vit plus half at square, right? X. Isaac, can you tell me? Don't do that. Then I have to edit video too much. What is the acceleration at the x direction?
Zero.
Due to gravity? 0. All right, so Vix is equal to dx over t. What is dx?
2.
What is t?
0.8.
So 20 over 8, which is, of course,
It's
5 over 2.
2.5.
2.5 meter per second.
Can do basic math.
Excellent.
You could
Okay.
do it without a calculator.
5. Problem 5.
Ow.
A ball is rolled twice across the same level lab table.
Okay, good.
Friction
Number
is
5.
allowed to roll off the table and strike the floor. In each trial, the time it takes the ball to travel from the edge of
Okay, does it matter? Ball roll 2 times, 5 times, 100 times, 200 times.
No.
At the edge, however, ball has how many velocity? Vx and Vy. Absolutely, right? Yeah, absolutely. So Vy has to be what? Brahmagupta.
What?
Yes. And
So what is acceleration? Isaac Newton.
that's right. Okay.
So what's the value of the field tensor? Albert Einstein.
Okay, that's right. Okay, so what is Vy? Brahmagupta. What is Brahmagupta? 0.
So what is the value of the absorption constant? Beer.
Okay. All right. Good.
Beer's law.
What are you trying to find?
V
Height.
Height.
Okay. So the height is height. Height is d is equal to VAT plus half at square. Now, x, Isaac, x or y? Which one gives you height?
Y.
Oh.
Y. Good. Well, okay. So height is equal to what? V on y is 0 plus half 9.8 t squared. I gave you t.
0.39.
0.391.
Oh, we're not getting any challenges anymore?
Yeah, I'll give you the challenge. Height is how much?
0.75.
0.75. You like challenge? You like challenge? Okay, what is the next problem? Read.
Jack in the Box is a toy in which a figure in the open box is pushed down through pressing a spring. The lid of the box is then closed. When the box is open, the figure is pushed up by the spring.
All right.
The spring in the toy is compressed 0.07 meters by using a downward force of 12 newtons.
Okay, good. So Jack in the Box, what happened? Is pushed down by a what?
Spring.
The spring, right? Applying some force. Force causes the
The
displacement.
answer is choice 1.
Yeah. Force. How much force causes how much displacement?
12 newtons for 0.07. And Hooke's law states, shut up. Because
Okay.
you did too.
So if you release, what happened? If you take up the, if you release it, what happened?
It jumps up.
Jumps up.
If it jumps
That
up.
doesn't really matter because F equals Kx states that since X is 0.07 and F is 12 newtons,
Good.
then K is equal to 12 over 0.07.
All right. F equal to Kx. What is the name of this equation?
Hooke's law.
All right. H equal to
Watch it once
X.
after you think you're done editing.
F is how
You
much?
catch anything.
F is
12.00.07, right?
Yeah.
So K is equal to 1200 over 7. Is it 150?
It's
Yeah,
171.
171. 171 Newton over Newton per meter. Okay. Can you read problem 7? Isaac, can you read problem 7?
240.
Okay. So what happened?
Oh no, not yet. Molotov. Yet Molotov.
don't use my chance.
Okay. Okay, got it. Yeah, it's 4. It's choice 4.
All right. Can you help me out now? What do we need to find?
The resultant.
Resultant of what?
The resultant of these
Of
two
this two
vectors.
vector. Okay, good. Can you tell me what is this one?
The resultant.
Resultant of what?
The resultant of these
Of this two vector. Okay, good. Can you tell me what is this one?
Well, from my calculations, it seemed to be 100 degrees. No, sorry, 80 degrees.
Raf, what is this one?
80 degrees.
Okay, that's all you need. 80 degree, right?
Mm-hmm.
If it is 80 degree, then r square is equal to a square plus b square plus 2ab
I get 4.
cosine 80.
Yeah,
okay.
so-
So r is no. You can show me later. A is what? 10 square plus b is 10 square plus 2 10 10 cosine 80. Can you tell me what is this one quickly? Both of you type it in calculator. And Isaac, you can show the other way of doing this one.
So the other way.
No, you do it here. Other way. Raf, what is this one?
The other way is notice
15.3.
15.3. Is this answer choice?
15.5 is answer.
Yeah, so that's good.
So this is not just 80, but it bisects into 40 and 40.
Objection, you can't assume that.
No, I measured it with my protractor. Stunt. So then, since they're going in the opposite direction but have the same angle to the normal, that means their x components cancel out, so we only need to measure their y components. In other words, we have to find the sum of sine 40 times their lengths, which is just 20 sine 40, or about 15.
Oh wow, good. Save time.
Okay.
Block along a horizontal frictionless surface. This block then collides with a stationary 1 kilogram block. He wrote, "I'm dumb, Suborno, he." The blocks
That's
remain.
part of the question.
No, it's not.
Okay. All right. So what is the K?
600.
2600 Newton meter. And what else is given? That's it. Oh, how much it is compressed?
0.1.
0.1. All right. So potential energy on the spring is half kx
Okay,
squared.
got it.
So half 2600 is it 13?
Yeah, 13.
0.1 squared. So 1300 times 0.01, which is 13 joule. Now I'm gonna make guys. I'm gonna make this problem little serious, right? Can you find the velocity of this one? All right. This will what happen after collision?
Stick together.
After collision, this is stick together. Do I have to give you the mass?
It says already 1 kilogram and 3 kilogram.
Oh, this is 1 kilogram.
No, that's 3.
That one is 3.
3 kilogram, and this is
1 kilogram.
This
the
is-
one it collides with.
okay. So this is 1 kilogram. So 1 kilogram and 3 kilogram. Can you find the velocity of this?
Yeah.
Isaac, do here. Raf, do over there.
And it's being pushed just like so. So that means that we have 3 is that. Oh shoot, wrong direction. That over that. Please don't steal me, calculadora. So that seems a little high, but we'll go with it because then.
Don't you think so? You have to use M1 B1 plus M2 B2 is equal. Okay.
Okay. Oh yeah, you're right.
Okay, done.
What? Oh God, he was right. He was right all along.
Yeah, I think so. I'm not sure. I didn't do it before. Did you use M1 M2 M1 B1 plus M2 B2?
Yeah.
Okay. So Isaac, you want to do it? M1.
Wait, let me try.
Isaac want to yeah. Why work? Kinetic energy is equal to potential energy, right? I'm sorry. Potential energy is equal to kinetic energy.
Yeah.
Well, one done, the other was okay.
No, do it. Try.
Okay, let's try this. No, that's bullcrap. I'm sorry. Okay, you have M1 V1 plus M2 V2 equals M1 V1 prime plus M2 V2 prime.
At the end, you have only one velocity, so you just factor out
I
the.
got it.
Okay.
I got it. M1 plus M2 V prime. Great. Now we have 2 variables.
Don't look at the answer.
Let me think. Oh, right. Right. That's what it looks like to me, at least. So then we get that.
Half mv squared. M is 4. What is? Oh, I see.
What?
Let's see if we get.
Is it 2.5? 5?
You got 2.2.
No, why did you?
So you see which one momentum is conserved quickly. Which one momentum is conserved quickly. If momentum is conserved, then you write. If your momentum is conserved, you write. Go. Plug in 2.2. Plug in 2.55. Go. See, momentum is conserved.
But we don't even know the value of V1.
We do. I think he made a mistake.
Oh, he made a mistake?
Can I help him?
Yeah.
Okay. So here is your mistake. Look. This is how you do it. The potential energy of the spring.
Yodel.
Listen.
Oh, you're right. I got
Can I
it.
finish?
No, I got it. So we get the potential energy of the spring is equal to half 3 V1 squared. We get 26 over 3. Why are you creeping up closer to me, you weirdo?
Did you square root it?
Yes.
Okay.
Okay. 3 times 2.94 equals 4 times 2.55.
Divide both sides by.
What?
No. This is wrong. I'm telling you. Solve for the final velocity.
Can you just let me test it for like 2 seconds? Oh yeah, you're right. This one is way a little greater than 10, while this one is less
is
than
wrong.
9.
No. It's wrong. That's what it is.
I got it. Thank you.
Okay, so answer is 2.22, but you need to show that the momentum is conserved. If momentum
But
is
you
conserved,
literally
Can
found
I
it
do
through.
it? Can I do?
yeah, momentum is conserved. No, use the equation he wrote. V1 M1 V1 plus M2 V2. Okay.
You literally found it through conservation of
No.
momentum.
I
Why would you need to conserve it
I
again?
used a sophisticated method.
No, you're just dumb.
Let's see.
V1
Yeah.
is 2.94,
Okay.
and I found that V2 is 2.2. So now let's see. Let's plug in the calculator. So 3 times 2.94 is 8.82. What are the units? Kilogram.
You don't need that.
Okay. 4 times 2.2, 8.8.
Which is okay.
Yeah.
Okay. Sure. Can you give me a frequency equation?
1 over T. 1 over T.
1 over T. Or another frequency equation?
V over lambda.
Frequency is the cycle over time. Period equation?
1 over
Time
T.
over?
Cycle.
And the period equation?
Do you think he's overcomplicating this problem?
T.
Not T.
1 over F.
1 over F. Which one are you using? 1, 2, 3, or 4?
The first one.
Okay.
4.
No. How much is this?
340.
Frequency is 340.
How much is this?
4. 2.94 times 10 to the minus third. Aha! I got it!
It's the weight of the ball.
Oh, he'll get what's coming to him.
400 Newton?
No, 4 newtons.
4 Newtons. Okay, like this? Okay.
What is the weight of the ball?
So what is the weight, Isaac?
Oh, I can find it.
Okay.
It's just
Use 10 or 9.8. Doesn't matter, 9.8.
Wait. Okay.
I don't think he understood the problem.
So it's sliding to the right, which means the force of friction.
No, you don't do that. It's just,
No, you just find the weight. You just find the weight. 0.2 times 9.8.
I'm in denial that it's this simple.
Yeah, it is.
It can't be this
It is
simple.
simple.
So FF is equal to mu Fn. Trust me. This has to work.
No, Suguna. Just 0.2 times 10 is
Yeah.
It's 1.96.
Yeah, it is 1.96.
Yeah, 1.96.
You got 2.
I got 1.96.
Yeah, 2 is because he used the.
Then what's the point of providing copper on steel?
In the future, you can complicate it.
What?
So this 0.2, 9.8, or maybe someone want to do this way, and it works out that way as well. Okay. Number 11.
Above the surface.
Let's see who can do this faster.
Oh, okay.
All right.
What's the question?
Question number 11. The 2 kilogram box is 1 radius away from the earth surface. 2 kilogram. Isaac is not doing the best optimal way, although he took calculus. Okay, all right, sure.
Okay. So we have. Oh yeah, I got it.
Okay, done. This choice
9.8 over 4, which is 4.
Choice 4.
9.8 over 4, which is 4. In what world?
No, it's choice 4.
Or choice 4,
Dummy.
which is 2.5.
Yeah.
All right. Okay.
It took you that long?
All right.
So we know that the normal, ordinary.
Okay. Isaac, explain this problem, and Raf, you're gonna explain this problem. Let's see whose explanation is better.
So normally, if you have an object on top of the Earth, then it's 1 Earth radius away from the center where the force is being exerted. So that means that the normal acceleration would be gmm over r squared divided by m. So this would be the acceleration. So then you get a is equal to gm over
Good.
r squared.
Good.
However, we know
That's
from our
9.8.
this reference table that that's 9.8. Please don't interrupt me. Meters per second squared, of course. So then,
But I would say Newton per kilogram. Okay, they are the same. Okay, good.
don't be naughty now. Alright. So then, when we're 1 Earth radius away from the surface, we're 2 Earth radii away from the center. Which means that by the inverse square law, the acceleration is now gm over 2r squared, which is gm over 4r squared, which is 1 over 4 times gm over r squared. But wait, we already know this. So this is just 9.8, and this is about 2.5. And this is wood, and the floor is wood.
Okay, what did it ask you to find?
The horizontal.
Oh, that's very easy. 150 cosine 30. No. How much is this? Quickly. I'm going to make it difficult. 130. Now, for you, I'm going to make it difficult. I'm going to ask you to find normal force. Go.
Oh, okay.
Because it's the original weight
0.52.
minus how much?
Yeah, 309.52.
What is it? Normal force?
309.52.
Oh my God, Jesus Christ. Normal force is, of course, what is the y direction of the applied force?
75.
75. And what is the weight?
150.
How do you know that?
You don't know the weight?
We just found it.
No.
What is the weight?
Oh.
This is 130, which is the
Oh,
component.
that's not the weight?
Are you stupid?
Oh.
So,
Where does he get his ideas?
wait, Isaac.
309.52.
And what is the normal force? Normal force
same
is...
thing.
No!
Oh, no, the weight is this. Sorry. The normal force is this. The weight is that.
Can you write nicely so a human being can understand it?
No, hunky. Okay. 384.52 is
130.
the weight, and 309.52 is the normal force. Confident.
Oh, so the force of friction has to be equal to 130.
Can I show you how?
Yes.
Alright. Well, we know that.
At least you have to write weight symbol and normal force symbol.
Okay. So, this is.
433.
What is he doing? You're supposed to use the static friction, not the kinetic friction.
No, it's
at
moving.
constant velocity.
Constant velocity is moving. So you have to use 0.3.
Are you okay? How many physics mistakes you made?
How many physics mistakes did you make?
No,
You
no,
thought
no,
it was going this way,
No, no,
and then suddenly, oh no, that's the weight now.
All right.
This is just equal to FF is equal to 0.3 Fn. We know since it's at
Wait, the
constant.
weight is not 433. Where did you get? That's not the weight, that's the normal
Oh, you're
force.
right. You're right.
The weight is 75 newtons greater than this, which is 500.
508 actually.
Whatever. Yeah, 500.
Can you use, guys, can you use the notation Fg for weight and Fn for normal force?
So Fn is equal to 430. Where does he get his ideas? At a constant speed by applying a force of 25 newtons parallel.
Oh, you want to do it? Okay.
Alright. No, why don't you come up here?
What
And if this is 32, and you get 411.5.
20. It is the same answer.
So it's 20.3.
Okay,
Yep.
good. All right, good.
I fricked up.
Okay.
Yeah, admit I made a mistake.
I made a mistake.
No, now say I am.
Well, I mean, it's going up the hill in this direction, and the graphic shows that the force is this way.
Okay, so can you write also displacement, the vector next to the vector? So, and the value and their values.
The value of the displacement vector?
Yeah. It's given.
It's given.
Okay.
And the value of the force vector.
And the value of the force vector, right.
All right, okay. Now put them in the incline. Put the box on the incline now.
Uh-huh.
Okay. All right, okay, now do it. That's it.
Then work does the magnitude of force times the magnitude of the displacement.
You even don't have to do that. You have to write cosine theta so people understand that. No. People understand that. The both vectors are the same direction, so it must be 0. Yeah. Cosine theta. Never forget
I learned
that.
that somehow it was a miracle that I didn't fail the regents. Sorry.
Why you? Oh my God! This guy is. Why did you write Saturn?
That's just
Sun. Why did you write Sun?
Just because. Oh my God! That was a distraction.
Yes.
You can't do this to me.
Now next thing you're gonna write house.
You can't do this to me, Dad.
Okay.
What the hell? Oh my God, there were so many distractions. I'm having a hard time filtering them all out. Oh God, I'm gonna die. 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 I'm gonna die.
Okay. Choice. I won't say it out loud.
Damn it, 3.53.
That's wrong.
I know it's 3.53, you bastard!
3.52.
It's fine.
Okay, no. Can't do that on live camera.
This one Vx, this one Vx, Vy. Isaac, can you tell me what is Vx over here?
10.
For scenario 1, 10. Can you tell me Vx for scenario 2?
20.
Can you tell me what is Vy for scenario 1? 0. What is Vy for
0.
Brahmagupta?
Brahmagupta.
Okay. So T, okay, Isaac, which one T is bigger?
Neither.
Raf, which one T is bigger?
Same.
Good, T is same. So T is equal to T.
Neither means not 1 nor 2 or 3.
So can you give me just T? Just give me a T.
5.
If this one 5, this one is?
5.
So if this one range,
That's a lie, it's not 5.
No, it's 5.
no, it's just we are making it up. So what is the dx over here then?
50.
Because 10 times?
5.
And what is the dx over here?
100.
So what is the answer?
Wait, twice.
2D. 2D, yeah, that's the answer. Okay, 17. 158 Newton. And displacement is?
230.
230 meter. So what they ask you to find?
The work done by the rope.
Work done by the rope is FD cosine theta.
3630.
158 times 230 cosine what? What
0.
So how much is this?
363.
36,300.
363?
Actually, it's 36,340.
That's okay.
3634.
36?
340.
Why don't you say it?
340?
Yes.
Joule? Alright, that takes us what number?
20 Newton.
20 Newton. And the constant velocity is 3 meter per second, right?
Yeah.
Can this one ever be 21?
No.
Can FF be 21?
No.
Can FF be 19?
No.
Okay, why? Why FF cannot be 19? Because net force has to be net force has to be 0, right? So if net force has to be 0, then what does that mean?
The force of friction is minus 20.
All the forces has to be equal. Okay, so 20. Okay, good. I just gonna get distracted again, like just like before one. He's writing all the information. Rifat is done.
What?
The other guy is reading all the information.
Wait, but a photon doesn't have. Don't you do this? Oh!
Oh, he wrote HF. He wrote the Planck constant.
Oh, poor guy.
The answer is there.
Oh,
That's unfair. I don't have a full ruler.
you do. Trust me.
I have to combine them.
Oh my gosh, he's an idiot. Okay. Got it. It's 4.
That's not fair.
It's 4. It's 4.
Wait, wait, wait.